Hello and welcome to yet another Chi-Prime video where we try to solve a problem to prepare for the GMAT. As usual, I'll give you a second to read the question and pause the video if you'd like, if you want to solve the problem yourself, and then we shall proceed to solve it together. Alright, so let's begin. Here you're given three functions, fib of n, which gives the nth Fibonacci number. The Fibonacci series is a series as described here. Here it starts with 1, 1, 2, 3, 5, and so on, where each number of the series is the sum of the previous two numbers of the series. You're given a function pow of kn, where that returns the nth power of the number k, and you're given the third function fact of n, which gives the factorial of n. So let's just solve this by looking at, this is one of this slightly harder problem that you would see. So let's look at solving this by computing a few numbers in the series, so just so we understand it correctly. So you have 1, 1, 2, 3, 5. The next few numbers in the series will be 8, that's 5 plus 3, 13, that's 8 plus 5, 21, that's 8 plus 13, and so on, right? So this is the Fibonacci function. The pow function, and here k is given to be 2, because if you look here, it says k equal to 2, and n is the number that, so n goes from 1 to n is what we're given here. So here it would be 2 to the 1, that's 2, 2 to the 2, that's 4, and so on. And you can already see that this function grows much faster than the Fibonacci function. Both of them are increasing, but this function 1, 2, 3, 4, the fourth term is 16, you're already way above the fourth term there, and it's growing much faster also. In fact, it's going to hit 3 digits very, very much earlier than the Fibonacci. So you know that the pow function is actually going to grow much faster than the Fibonacci. So you can use that directly, since we're saying values from smallest to largest, to eliminate any of the options where the Fibonacci has a higher rating than the power. So for example, B is one such option where Fibonacci is higher than power. We can eliminate that. And also D is an option where Fibonacci, B is an option. D actually is still in play. So we can still consider D. All right, so we've established that fib is less than pow. Now we have a more interesting challenge. We have pow and we have the factorial function, right? So let's look at a few elements of the factorial function. Essentially, we want a series which is like this: 1 factorial, 2 factorial, 3 factorial, 4 factorial, and so on. 1 factorial is 1. 1 times a 1 is 1. 2 factorials, 2 times 1 is 2. 3 factorials, 3 times 2 times 1, that is 6. 4 factorial is 4 times 3 times 2 times 1. So 4 factorial is 4 times 3 factorial, right? 3 factorial is 3 times 2 factorial, and so on. So 4 factorial is 24. 4 times 3 factorial. 5 factorial is 5 times 4 factorial, which is 120, and so on. Now, in case you didn't follow that, n factorial is n times n minus 1 times n minus 2 all the way to 1. So this is equal to n times n minus 1 factorial. That's how we get it, because n minus 1 factorial is n minus 1 times n minus 2 times all the way to 1. Okay, so that's how we simplify this. Now, if we compare this function, the factorial function, and the power function, we see something interesting. In the power function, in pow of 2 comma n, the next term is always 2 times the previous term. Whereas in fact of n, from this formula here, from this formula here, the next term is n times the previous term. So as n grows, if n is greater than 2, which it is for any term greater than the second term, this function will grow faster than this function, right? You're multiplying a number, the previous term by 2 in the POW case, you're multiplying the previous number by n in the fact case. So factorial grows the fastest. So our conclusion here is Fibonacci grows slower than POW, which in turn grows slower than fact. So now we have to find an option that suits that. Option C, POW is less than Fibonacci. We know that's not true, so that option goes away. Option D, POW is larger than factorial is larger than Fibonacci. No, that's not true, because as we've said before here, we see that factorial grows faster than POW. So we want the options in the order fib, POW, fact, and that's what we have in option A. That is the correct answer. So this is an example of a problem where it's easier to solve if you try to figure it out by working through some example values for a function that's given to you. Thank you for watching.